So this calculator page, like I said, just needs to get glued in. Okay, it's just for your reference. This page right here will get glued into your journal. Okay, it needs to get glued in sideways so that it fits right. Okay, preferably with this at the top, because this pink page you're going to cut so that you have flaps. Okay, so just cut along these two lines in the middle so that you can have flaps. And then you're going to glue or tape just this strip at the top up here to it.
And that's the second thing? That's the second thing?
And that's the second thing that goes in your journal, yes.
I'm so confused. What's the second thing that you're gonna do?
This foldable thing. This goes on the back. You put this behind it. Yes. Okay. And put it, you'll have to put it upside down. That's why I'm putting it like that here. So put it, you can put it this way if you would like, but put it so that it fits all on one page. And then this strip right here, you're going to put glue or whatever on, or just tape this across the top of it. And so you will see that underneath this flap of the graphing gives you all the steps of what we're going to talk about today. Substitution flap, okay, gives you step by step what we did on the video on Wednesday last week. Okay, so if that you were looking at your notes over the weekend trying to figure out how to do substitution and you got lost because you didn't know what to do next on your notes, this is a good step-by-step instructions on what to do. Okay. The same thing underneath this elimination flap. Okay, this is what we did in the video on Thursday. And so if, again, this weekend you were working on stuff and you didn't understand how to do it, or remember what the next step was or whatever, then this walks you through step by step what to do for the elimination process. Okay? So there's nothing to be written in this. It is just an additional tool for you so that you have it to help you remember what to do step by step. And then lastly is this one, and this is the one that we're going to take notes in today. It can be glued in, but I might wait till after we finish doing notes because sometimes it's hard to graph when it's in your journal. Okay, so this will be next, and it's what we're taking notes on. Okay. If you did not grab a classroom calculator, you will need that as well. So while you're waiting on others to get to this point with us, go get you a classroom calculator and get it cleared using those brown steps that are up there on the board. So at the top of this page, it says to solve by graphing, find the point of intersection. What does the point of intersection mean? What does the word intersection mean?
Where they cross each other.
Where they cross each other. Just like two streets, right? Two streets will cross each other, and you call that an intersection where that they cross over each other. So that's what we're going to be looking at when we're graphing today. We're going to be looking for that point of intersection. In this, on this clipboard in the blanks over here, we have a system of equations is a group of two or more equations with the same set of variables. Okay. In order to be a system of equations, they must have the same variables inside those equations for you to be able to find a point of intersection. If they're not talking about the same thing, then you can't use the information from each one to solve the other one. So in this bottom section, in last week's videos, we already talked about all of these types of solutions, but let's recap today. So what would a no solution graph look like? Well, if to solve them, we're looking for a point of intersection. So if there's no solution, what would that mean? Do they intersect?
No.
No. So what type of lines can we have that don't intersect?
Parallel.
Parallel lines. So, okay, your parallel lines don't have to look exactly like my parallel lines, okay? But no solution means that they're parallel. You can. We will on the back for sure. So they never cross or never intersect, right? So notice on this over here it says, if both lines have the same slope and different intercepts, they are parallel. Okay? So they never intersect because they have the same slope and different intercepts. Okay? And you can write that where that you can read it better than what I put up here. Okay, so they never intersect. They have the same slope and different intercepts. And we talked about that being one of the definitions of parallel, right? When we were talking about parallel lines. So what about infinite solution? What do they look like? So we had parallel lines that never cross.
They have a point that they're the same point.
They're the exact same lines. So if I have a line here, okay, then a collinear line is going to be the same line, okay, or infinite solutions. I jumped ahead, means that they are collinear. Okay, infinite solutions is collinear. over here it says if they have the same slope and the same intercept, they are collinear. So over here, I would say that they're the same line, same slope, same y-intercept, okay? And they are always intersecting. Or intersecting at all points, or however you want to word that. So what about one solution?
They cross out one point.
They just cross at one point. So can they cross in the origin?
Yes.
Yeah, they could cross in the origin. They could cross at the y-intercept. They could cross wherever, right? So one at the origin and one over here somewhere. Okay, it doesn't matter. You draw two different examples of only one solution where that they cross at one point. Okay. So one solution means that they only intersect at one point. For this to happen, they must have different slopes. Okay. Because if they have the same slope, they're either going to be parallel or infinite solutions. So to have only one solution, they have to have different slopes. Is everybody done with that? If you did not clear your calculator, take this time to go ahead and clear it. Follow those steps over here on the board so you can clear it from what they were doing last class. This equation, when they're in standard form, we can graph them on Desmos when they're in standard form. Okay. That's the other link that I have. So those of you that are new to class, if you're not familiar with Desmos, that's the other link that I have in the agenda. Okay, but you can, well, I prefer you to use the one through the agenda, the link through the agenda. You can type in Desmos and you can download an app for your phone that's Desmos Calculator. That's a free graphing calculator online. The link through the agenda is just the testing version that you're allowed to use on the STAR test. So that's why I prefer for you to use that link, because it won't let you use anything or get used to using something that you can't use on the STAR test. Does that make sense? So, but Desmos, you can graph these. But we're going to go ahead and just do a refresher on how we could graph these, even though, can somebody tell me by looking at it, what's another method we could use? Because we've already learned the other methods. What method would you choose to solve this with if we weren't graphing?
No.
Elimination, right? Because these y's would cancel out, and then we could solve for it quickly. But we're not going to use elimination. We're going to graph this from standard form. So you can see what steps you would have to go through if that you weren't using elimination. Okay? So we're going to use the acronym that we learned in here. Can a chimp blow a bubble? Can it? Can it, guys?
No.
No, right? So that's why we have the minus sign right there. So this first, the C over A is my x-intercept. The C over B is my y-intercept. And the negative A over B is my slope. This says to graph with the intercepts, but I prefer to use the y-intercept and the slope. So we're going to use the y-intercept and the slope for these. So my y-intercept is what we need to start with. Can y'all see that green okay? Okay. The y-intercept is where we need to start to be able to graph. So C over B. How do I know what my number for my C is? What is my standard form? AX plus BY equals C. Remember? So they're in alphabetical order, A, B, C. So my C is 8. So 8 over my B, which is negative 2. So what does that reduce to? 8 divided by negative 2 is negative 4. So that's my y-intercept for this first one. So negative 4. I'm going to put a blue dot beside it or underline it in blue or something. So, because we're going to use two different colors for our graphing our lines. Okay. And then for my slope, I'm going to use negative A over B. So negative 5 over negative 2. Does that reduce any? Since they're both negatives, they would could both be positives because the negatives would cancel each other out. Well, if I'm using this and I want to just use my slope like it is, can I count down anymore? Do I have room to count down 5? No. So I'm going to have to simplify them to my positives. So I can go up 5. 1, 2, 3, 4, 5, and positive 2. So up 5 over 2. So there's my first line's coordinates or dots that I can graph. You want to be as accurate as possible when you're drawing your line, because that leads to mistakes in your answer if you don't. So now the y-intercept of this second one is C over B again. So 4 over 2. So 4 divided by 2 is what? Is 2. So my line this time I'm going to make red. So I'm going to go ahead and plot my positive 2. And then my slope is negative A over B. Well, remember we have that invisible 1 in front of there, so there's no other number. So it's going to be -1 over 2. Does that reduce anymore?
No.
No. So I'm going to start up my y-intercept and go down 1 over 2. Down 1 over 2 again. Because they're so close together, I went ahead and did 2 dots. Or 3 total. Make sure you have at least 2 coordinates. Okay, if your coordinates are really close together, then doing an additional one to make sure your line stays straight is always a great idea, especially when you're solving by graphing. Okay, so what coordinate did they intersect at right there? 2, 1. So 2, 1 was the coordinate. So now we're going to go to the one right below that. And this is where we're going to learn how to use our graphing calculator real quick. Okay, did everybody finish doing that? Okay. So your solution should be over here in this box, 2, 1. Okay. So down here in this next example that we're going to do, notice that both of these are in slope-intercept form already, which is what form we need them to be in to be able to use our calculator. So first thing is, of course, turn it on, right? Okay. For those of you that are new, this always comes on because it's locked out of things you can't use on the STAR test. So hit enter and just hit OK. So most of the time in here you use the Find Calculator button. And so when you open up the Find Calculator button, this is where the calculator page is at. And if you hit that calculator button again, it's going to take you to this graph that's also there. At the beginning of the year, we talked about f of x being the same thing as y. Okay? So this right here is the same thing as saying y equals. Okay? We are not going to retype y because the calculator needs it to stay in function notation in order to graph it for us. So we're going to leave that there. So we're not going to type our y equals in. We're going to start because y equals is the same as the f of x. Okay? So instead of y equals, we're just going to leave that there and start with 1/2 x minus 1. Now to get that to look like a fraction, again, for those of you that are new, hit the control and the divide button. That will automatically put it in a fraction form for you. Okay? So 1/2, use your arrows to get from the top to the bottom, and then get out from underneath your fraction by using the over arrow. Your letters are at the bottom, so 1/2 x minus 1. And if you hit enter, you will see that you get a blue line on the screen. I want to be able to tell more details that's on here. So I want us to change the view on our calculator, on our screen right here real quick. Okay, we're going to hit menu, and we're going to go to this number 2 right here that says view. So you can either arrow down to number 2 or you can hit the number 2, either way. Okay, hit enter. And I want to show this the grid. So I'm going to go down again to number 2 and hit enter. Okay. The lined grid is what you're used to seeing on your paper like this. And if you like all those lines on there, you're more than welcome to change it to the lined grid. I prefer for the screen here to just have the dot grid because it kind of gives me the same information without being so overwhelming that I can't tell things apart. So I'm going to do the dot grid. So you can see, I can see where my lines would be at on here without having a ton of lines on there to be overwhelming. But it helps me see where my coordinates might be. Okay, so give me 2 coordinates that I can plot for this first one. And because it's blue on my calculator, I'm going to do it blue on my paper as well, just so I don't get confused. So what's one coordinate that I can graph? Can I graph the y-intercept? Right there at -1. Then it looks like I can also graph the x-intercept. Okay. So now I have 2 points and I can graph my line. Now I want to go back and if I typoed something and I need to fix it because it doesn't look like this, or you need to do the second one, you're going to hit the tab button. Okay, that will pop back up this entry spot for you to put your equation on. So if you made a mistake and you need to go back and fix something here, like say you put -1 instead of -1, so the calculator did times -1, then you would need to go back and backspace and change that to say -1 for your calculator. So if you're good there, you can arrow down, or it would already be there for you usually. Okay? And this is the F2 of X is just telling me this is a second line that I want to graph. So it's not the same line, it's a second line, right? So I'm going to type it in. Again, the control divide gives me the fraction. So 7/4x plus 4. Hit enter. And you should get a red line that looks like that. Notice that your lines are labeled with what the equation is. Okay. So can you give me a couple of coordinates for this one?
Which one?
For the red one, so I can graph it on here.
+4 going up.
+4 going up.
-2.
No, but it's not really there. It's kind of there, but not. That's why, to me, the dots help because I can see if it really goes through that point or not. Like this one looks really close, but it doesn't really go through there. So, but it does go through right here where they intersect at, which is -4, -3.
I can barely even see it.
So on your calculator, so notice that I didn't even draw my line straight. That's some of the disadvantages of this, because if we're solely relying on our skills of drawing straight, I didn't even get my line straight. Let's go through the coordinate there. So okay. There is something else I want to show you from this though. Okay, Malaya said it was kind of hard for her to see that and see where it was and see what that coordinate was. So this is the main reason why graphing them on here, even though it's limited to what you can graph, if you need a table, this one works great for you. Or if you have a table that you need to graph, this works great. Okay, so if you will go and hit control, just the control button, you don't have to hold it down, and then the letter T button, what happens on your screen? You get a table up there, right? So Control T for a table. Over here in this column, notice that this column here is all of your X values. Right? So these two columns right here give you your Y values for your blue line, okay, when X is whatever it is over here, or your Y values for your red line when X is whatever it is over here. So I wanted to be able to see both of them. So I arrowed over so I could see all of this one. Now, if you want to know where they cross at and you're not sure, then if you keep going up, arrow up, you know it's on the negative side of the X's. So we need my X's to start going down, which actually means we're going up on our table. Okay. So notice right here, when X is -4, both my Y values, let me try a different color, both my Y values are -3. Okay, so when X is -4, both my Y values are -3. So that is where my point of intersection is at, because that's what I'm looking for. I'm looking for when are my Y values the same, when my X is the same. Okay, so my solution here is -4, -3. So I want you guys, okay, so Control T will also take the table off. So if you don't need it, okay. So I want you guys to practice and do this one on your graphing calculator, okay, on the calculator. So again, to go and change stuff, you're gonna hit Tab, okay, and it'll pop up arrow up, so you can erase everything. So arrow up and then delete, so backspace, right, and then type in, okay, it accidentally took my equal sign away. Your equal sign is just underneath the control button, so hit equals again. And type in your first problem there. It won't change your lines until you actually hit enter or you arrow down for that next equation. So get those put into your calculator while I take attendance real quick because I forgot. Beginning of class. So your lines should look something like this. Just now. So to get the table to go away, and then hit Control T. So that and okay. And so if you want to go back and change the tab, that's for a new equation. You want to go and change your own ones and arrow up. And then One other thing that's cool about this calculator too is it's got a hand on it. So if you scroll over your the formulas that it has up there for you, the equations, and you need to move it, if you'll scroll your hand over it and then hold down that mouse button right here, it will grab it and let you move it so it's out of the way. Okay, so you can do that with both of them. You can actually do that to the line as well, so be careful because you may not want to actually be moving your line or your axis or whatever. But you can do that to move your graph up and down. So you can hold it and move your graph up and down as well. The screen that you see there. Change the graph entry method. And then change it up to function. So I'm going to go ahead and graph these really quick because we're running out of time. So here's that first one. Okay. So here's my point of intersection, which is -1, 4. Again, if you couldn't tell that or you wanted to make sure what your coordinates were, that Control-T, pop up that table, and then you can use it to find coordinates. So for my blue line, I could use the coordinate 1, 2, 3, 0, 4, -1, any of those. Okay. For my red line, I'm limited a little bit more because I can't go up to 10. Okay, so I can't use -2, 10, but I can use -1, 4, or 0, -2, 1, -8. Also, I'm limited. Okay, but there's coordinates for you to use there. Okay, so this one up here, what is a y equals number? It's just going to have a horizontal line, right? This one, you can graph on Desmos. You can use the Canachimp blow a bubble. You can rearrange it by subtracting 3x from both sides, which gives us 2y equals -3x plus 4. Divide everything by 2. So we get y equals -3/2 x plus 2. Okay, so by rearranging it, I now know that I have 1 at point 2 and then go down 3/2. And here's my second line, and there's my solution for it. This is also a great one to use substitution on because you already know what y is, right? So you can substitute it in and figure out what your x is. So it is 4, -4. Some advantages is that it's easy to graph if there's a nice integer solution, right, for it. But if there's not, then that's a disadvantage. If your numbers get too big, that's also a disadvantage. Advantages is it requires little algebra. The solution is visual, so you can see it. Okay. Some disadvantages is it's harder to get an exact solution if it's not integers. And your drawing has to be accurate. And then lastly, if you have really big numbers, then it's hard to graph on these little graphs. Yeah. So, your assignment, I wanted to talk about this really quick before that we dismiss. So your assignment, this front page has 6 graphs for you to do. Okay, make sure that you have at least 2 points, straight, accurate lines. They need to go all the way through your graph. It's up here in the instructions if you're not sure what I said. Okay, this page right here, you've got 1 graphing and then a substitution and 2 eliminations to practice before the quiz tomorrow. Okay, this right here, the choose a method, right? These right here are all bonus. Okay, all 5 of these problems are bonus questions, and they can earn you 3 points each towards the quiz tomorrow. So if you do these, show your work, and get them correct, you can get 3 points for each problem on the quiz tomorrow. So that's a total of 15 bonus points that you can earn. Only 1 graph, so only 1 of them can be graphed. The other ones you have to use either substitution or elimination.
Okay, so the second page is bonus.
The second page, this last page is just bonus. This whole page front and back you have to do. Yes. Okay. Any questions? I'll put these back up there so you can see those really quick.
I tried to get that other paper done. I didn't have time. I had to work.